Assalamualaikum grade 9 students. Model textbook chemistry grade 9, lesson book foundation. Here we have unit number 13, organic chemistry. In this chapter, we will study about the introduction of organic chemistry, what are organic compound, homologous series, structure formulas, difference between saturated and unsaturated compounds, chemical diversity of organic compounds, classification of organic compounds, functional groups. These will be our topics of discussion in this unit number 13, organic chemistry. I have divided whole chapter in the form of different questions, which can be in this question. In order to memorize this, you should focus on these questions related to the organic chemistry. Related to this chapter, I have generated 41 different questions. Let's see these questions. Okay, there's a mini worksheet. Consists of the question appear in the chapter number 13. Number one question is, what is organic chemistry? And what are organic compounds? You give 10 examples of the things in your surrounding that contain organic compound. And what is homologous series? Give also examples of these characteristics of homologous series. All the content, look at this, all the content present in this chapter. We will encounter all the content. I will give the link of this worksheet and then solve all the questions one by one for your understanding. Today we will solve first 5 questions. Number one, what is organic chemistry? What are organic compound? The examples of organic compound, the things in our surroundings, homologous series, characteristics of homologous series. Let's begin with question number one. What is organic chemistry? The answer will be the branch of chemistry that deals with carbon containing compounds and their derivatives. Derivatives contain carbon, oxygen, nitrogen, sulfur, phosphorus, etc. Except carbonates, bicarbonates, oxides of carbon, sulfides, etc. Why these carbon containing compounds are not organic in nature? The reason is that in this organic compound, carbon and hydrogen, carbon should directly attach to the carbon and carbon should directly attach to the hydrogen. In these compounds, like here is oxides of carbon is carbon dioxide, carbon monoxide. All of these contain carbon, but these are not organic in nature. The reason is that here carbon is not directly attached to the other carbon atom or hydrogen atom. So these are exceptional carbon containing compounds that are not included in the organic chemistry. Then we will get the definition, the branch of chemistry that deals with the carbon containing compound and their derivative except these compounds. Okay, this is our first question of worksheet. Then let's move toward the second question. What are the organic compounds? Okay, I'm giving you a trick, like if someone is asking about what is or what are organic compounds. Okay, so will be what are the organic compounds? The branch of chemistry, we will delete this one. The compounds that contain carbon and their derivatives. Same definition will be here for organic compound. What are organic compounds? The compound that contain carbon and their derivatives, except carbonates, bicarbonate, oxides, and etc. You should mention also these. The definition of organic chemistry and the definition of organic compound is slightly similar because we are dealing with the same kind of compounds. Okay, our next question is, what are? Oh, sorry, we have the third question in our worksheet is, give examples of the compound or the things in our surrounding that contain organic things, organic compounds. Okay, for this, okay, that question is, give examples of things around us that contain organic compound. In this question, you have to give the examples from your surroundings which have the organic things in them. Okay, answer will be, let's list the 10 things. Number one, our food. Number two, paints. Number three, plastics. Number four, fabrics. Number five, glues. Number six, artificial sweeteners. Number seven, ink. Number eight, rubber. Number nine, varnishes. And number 10, soaps and detergents. These are the few examples of the things from our surrounding that contain organic things. Okay, let's move toward the next question. What? Question number 4. What is homologous? What is homologous? Give examples to explain your answer. Okay, now let's write answer. The series of organic compounds that differ by adjacent molecule by unit CH2. Now let's take the example. The series of organic compounds differ by the adjacent molecule by unit CH2. Now let's understand with the example of alkanes, alkenes, alkynes. As we know that alkane are single bonded, double bond, triple bond. The first member of alkane is CH4. The second member is C2H6. Third member is C3H8. Now focus on this. There is one carbon, four hydrogen. I'm adding CH2. I'm just adding CH2. One carbon addition, it became two carbon. H2 addition became at 6. After this, add CH2. We will get CH3, 2 carbon, 1 this carbon, 3 carbon, 6 carbon, 2 this carbon, 8 carbon. Similarly, the example for alkene is also examples of homologous series. The first member of alkene is C2. First single carbon does not exist in alkene. C2H2. Sorry, H4. And then C3H6. Now look at the difference C4H8. Now look at this difference. We have ethene after addition of CH2, 2 carbon, 1 3 carbon, and 4 carbon, 2 carbon is 6 carbon. Similarly, add CH2, 3, addition of 4, 1 carbon, it will be 4 carbon and 8 carbon. It means the first member is different from the second member, or third member or whole member. Each member is different from the previous one by unit CH2. Only addition of CH2, you will get the next member of this homologous series of any homologous series. Now take the example of alkyne. Look at this. Alkyne have triple bond. It starts from C2H2. Ethyne. Then C3H4. Add 1 carbon, C4H6. Now what I'm doing? Just addition of CH2 unit. 2 carbon and 1 is 3 carbon. 2 carbon and 2 carbon is 4 carbon. Similarly, add CH2, 3 carbon plus 1 carbon, 4 carbon, and this is an example of homologous series. Now if you want to write the alcohol, as we know that the first member of alcohol is CH3OH, methanol. Now add CH2, C2H5OH, C3H7OH. Now what I'm doing, on the addition of CH2, we will get the next member. Carbon, 3 hydrogen, that is 2 carbon, 3 plus 2, 5 carbon, 5 hydrogen and OH. Similarly, 2 carbon and 1 carbon is make 3 carbon, 5 hydrogen, 2 hydrogen, 7 hydrogen, and this is the example of homologous series. We will continue up to 10 and more. We will continue up to 10 and more. We will continue up to 10 and more and more. In all the compounds, we will get that the homologous series, in the same homologous series, for example, for alkene only, the next member is different from only the unit of CH2. This is the all about the homologous series introduction. Now, one question should be raised in your mind: what are the characteristics of homologous series? Now, next question is to discussion about the characteristic, the main points about the homologous series. For this, I will write here the characteristics of homologous series. Number 1, in homologous series, functional groups should same. Number 1, same functional group. Characteristics. Number 2, general formula should same. General formula should same. Number 3, adjacent family member should differ by CH2 unit. This is the third characteristic. And same chemical properties. All the homologous series should have same chemical properties. But because electronic configuration or electronic configuration matter for the member. Similarly, the last point or last characteristic, It should give the proper trend of physical properties. Trends of physical properties. There is another question 5 we have solved in this, that characteristics of homologous series of this one. We have 5 characteristics. Number 1, same function group. Look at this, all have single covalent bond, double covalent bond, triple covalent bond. In alcohol homologous series, all have OH function group. All the homologous series should have the same function group. Number 2, general formula should say. If we start the general formula for this one, C2H2N plus 2. This general formula for alkane. For all the alkane members, we will follow this general formula. For alkene, C2H2N. We will follow this general formula for alkene. Similarly, for all alkynes, C2H2N minus 2. We will follow this general formula for all alkynes. For alcohol, C2H2N H2N plus 1 and then OH. We will follow this general formula for alcohol. The general formula for whole homologous series should say for this same, for this same, for this same, for this same. Now the third property or characteristic, adjacent family member should differ by CH2. As we have already done with this adjacent family member are differ by the previous one with the unit of CH2 in all the cases. The third property, same chemical properties. As we know that all contain carbon and electronic configuration of carbon in all the cases is same. So in homologous series or in the case of other compound, if there is a trend that chemical properties is similar if they contain similar kind of atoms. Similarly, the last one is the trend of the physical properties should be proper. There should be a trend. There should be a proper trend. Like if the first one is gas, then gradually the series should convert into gas to liquid, then solid. There is a proper trend. It will not like this. Like first one is gas, then solid, then liquid, then gas, then solid, then liquid. It will be not like this. There should be a proper physical trend. Like if the first one is the gas, gradually after getting the more atoms in them, it should convert into liquid, and after getting more atom, and then it should be converted into solid. And these are all the gaseous state and liquid things. Then gradually, if they increase the number of carbon, then it should convert into different things, different kinds of states. These are the few characteristics, and it is our question number 5. I hope you have get the all about these 5 questions from your worksheet. For other question, I will upload another video for the solution of those questions. Okay, thank you so much for watching this video.